Hello student, welcome my channel The Learn Physics with Dipak Majhi. Today I will be discussing the force and Newton's laws of motion. First of all, force. Force is the external form of push and pull. It produces or tries to produce motion of a body at rest. Look at this. This body is at rest. When a force acting on it, the motion is produced. Number two, the force stops or tries to stop a moving body. Look at this. This body moves along this direction with velocity u. When a force acting on it, the body comes to rest at this position. Now, third point, the force produces change or try to change the direction of motion of the body. Look at this. The direction of motion of the body is tangent to the circular path. Now, this force changes its direction and motion. Now, here this force changes its original direction of motion. Now, here this force changes its original direction of motion. And finally, force changes the shape of a body. Look at this. This is a wire. If a balanced force acting on it, its length increases. Now, classification of force. First of all, contact force. Look at this here, normal reaction. When a body rests on a surface, the surface applies a force opposite to the direction of the weight. This is known as normal reaction. And look at this. This is the tension. When a body of mass m is suspended by means of a string, then tension force acts on the string. The tension T always acts away from the body. The tension at any point of a weightless string remains same. And finally, the force of friction. When a body moves along this direction, the force of friction acts by the surface of contact on this body. This is known as force of friction. Now, this force, and also the spring force are electromagnetic in nature. Now, the gravitational force between the two mass, electrostatic force between the two charges, and magnetic force between the two magnets is the non-contact force or field force. Okay. Now, inertial frame of reference. The frame of reference which is at rest or uniform motion in a straight line is known as inertial frame of reference. A car is at rest or uniform motion in a straight line is taken as a inertial frame. Practically, there is no inertial frame in the universe. If the acceleration of the reference frame is negligible in comparison to the acceleration of the object to be observed, then it is known as it is taken as inertial frame. For a free falling body, Earth can be treated as a inertial frame. Okay? Now, non-inertial frame. An accelerated frame of reference is known as non-inertial frame. An accelerated car and accelerated lift are taken as non-inertial frame. Look at this. This block of mass capital M moves with acceleration A. So, it is non-inertial frame. A body of mass M on the non-inertial frame experiences a pseudo force of magnitude mass of the body and acceleration of the non-inertial frame and directed opposite to the direction of acceleration. Okay? Now, Newton's first law of motion. A body continues in its state of rest or uniform motion in a straight line unless it is acted upon by an external force to change its motion. Now look at this. This is the body at rest. So it remains at rest, and the body which is moves with uniform motion u, it continue in its state of uniform motion if no external force act on it. That is, a body is unable to change its state of rest or uniform motion by itself. This inability of a body to change its state of rest or uniform motion in a straight line is called inertia. Now, linear momentum. It is the dynamic property of a body which produces by mass and velocity of a body. The momentum P is equal to mass into velocity. It is as velocity is a vector quantity, so momentum is also a vector quantity. Its unit is kg meter per second and dimension m l t minus 1. Okay. Now Newton's second law of motion. The rate of change of linear momentum is directly proportional to the force applied on it, and change takes place in the direction of applied force. So look at this. From the Newton's second law of motion, force F directly proportional to the rate of change of linear momentum, that is P. So from here F equal to K dP by dt. Now look at this. So here K equals to d dt of mv. If mass of the body is constant, then look at this, Km into dV by dt. So now dV by dt is the acceleration of a body. So this is the Kma. Now if F equal to 1, M equal to 1, A equal to 1, then K equal to 1. Therefore unit force produces unit acceleration of a body of unit mass. Therefore 1 Newton force produces an acceleration of 1 meter per second square of a body of mass 1 kg. That is 1 Newton equal to 1 kg into 1 meter per second square. In CS system, the unit of force is dyne. Therefore, 1 dyne force produces an acceleration of 1 centimeter per second square of a body of mass 1 gram. So look at this, 1 dyne is equal to 1 gram into 1 centimeter per second square. Now look at this, 1 kg equal to 1000 gram. And 1 meter per second square equal to 100 centimeter per second square. So look at this. This is the 10 to the power 5 gram cm second square. So this is the 10 to the power 5 dyne. Now gravitational force of unit. The gravitational force of unit in SI system is kg force. 1 kg force equal to 9.8 Newton. And in CS system it is 1 gram force, and 1 gram force is equal to 980 dyne. Okay, understood? Now Newton's third law of motion. To every action there is an equal and opposite reaction. Suppose look at this. This is the two body, this body and this body. This body apply force F1 on this body, and this body applied force F2 on this body. So here F1 is equal to minus F2. Okay. Now this action and reaction force acting on two different bodies. If action and reaction force acting on same body, then net force F1 vector plus F2 vector, this equal to 0. Look at this. So no motion produced. That is why we can't pull a chair by sitting on it. We can't push a car by sitting on it. Okay? Many thanks for watching this video. I hope this video will be beneficial for you. Please like, share and comment on this. And if you are new, please subscribe my channel for new videos.